Okay, so welcome back to another video. In today's video we have the following indefinite integral. So we have it's a continued fraction over here. We have the natural log of x, then divided by 1 plus the natural log of x divided by 1 plus natural log of x, so on and so forth. It's infinite. And then of course that's multiplied with times 1 over x dx. So of course continued fractions is it can sometimes be a little bit difficult, especially, well, it's not so much difficult, but it's much more rather trying to find the pattern and then the way it repeats and then finding a way to evaluate this. Even if it's not specifically focusing on integrals or whatever, but it's more of just trying to find the pattern and then using that pattern to your own, accord to figure out how to evaluate it using that method. So of course that's actually the way we're actually going to approach this problem over here, find this pattern, and then hopefully we can rewrite this integral in the most easiest way and simplistic as possible. So first, let's see, we're just going to call this integral, I'll just call this I. So I is equal to this in this continued integral, okay, 1 over, or I'll just say dx or x. Okay, so what I can do is I can actually, we're gonna do a substitution. We're gonna do a substitution, but not exactly a u-substitution where we actually, differentiate some things and replace it. We're not gonna do that just yet. So first, we're gonna really focus on the continued fraction listed over here. So I'll call this variable u, then u is equal to ln of x and then divided by 1 plus, now you'll notice that we have the repeated fractions that's continuing, so ln of x divided by 1 plus ln of x plus 1 over x, so on and so forth. But you'll notice that that's actually just, we can define it as u. Simply, if you just plug u, if we set this back into here, this actually is going to repeat. So this is nice, because this way we can actually solve for u and algebraically. So if, you just multiply 1 plus u to both sides, so that way I get u squared plus u, that's equal to ln of x. Subtract ln of x to both sides, so that's u squared plus u minus ln of x is equal to 0. And as mentioned, we want to solve for what u is equal to. So therefore I can actually use the quadratic formula to find our solutions of u. So that way, so here we have that u is equal to, so let's see, this will be -1. You just plug in your ABCs into the quadratic formula over here. So 1 plus or minus the square root of, let's see, so b squared, that's 1, and subtract with 4 times, and then this is, since we're solving for u, so the x is actually in this case treated as just a constant. So that means, so let's see, I'll just put, that means we'll have c is equal to ln of x. So this will be 1 plus 4 times the natural log of x. And this is being divided by, so 2 times a, that's just 2. Now this is nice, so I can actually just substitute our continued fraction for what we have for u right over here. And so now we have the new integral, so that the new indefinite integral is that this is from, so I'll move the 1 over x to the front, so I'll just make things a little easier. Then we multiplied this with our substitution over here for u, so it's -1 plus or minus the square root of 1 plus 4 times ln of x, and then divide this by 2, and then dx. Now things will become very simple from here. So I can actually just distribute the 1 over x to, I can distribute the 1 over x into our, our substitution that we solve for, and then by using linearity, I can split this up into 2 integrals. So therefore, we're going to have the sum of integrals. So this will be -1 divided by 2x dx. And then, of course, there's a plus or minus over here. So plus or minus, then the indefinite integral from the square root of u of 1 plus 4 ln of x, and divided by 2 dx. We know that the first integral over here, this is simple. This is just basically, I can just factor out the -1/2, and so we have 1 over x, so that's actually just -1/2 ln of x. So now last is to calculate this integral over here, which that's supposed to be an x over here. There we go, because you multiply the x. Okay, but now this is actually really simple to show that if you actually perform a u-substitution, so if I let, this time, I'll let u, I'm just using the same letters again for notation wise, it doesn't really make a difference honestly. So if I let u equals ln of x, then we have that du is equal to 1 over x dx. I can factor out the 1/2 and then the x will cancel. So really we just have the, this will just be 1/2 and then multiplied with the indefinite integral of, what is it, the square root of 1 plus 4, let's see, so yeah, the x will cancel, and then so this will just be 4u and then du. And then you can actually just rewrite this integral, well, specifically rewriting the fraction, well, the exponent as a fraction. So this is just 1 plus 4 to the power 1/2 du. Then what I can do is when we have this indefinite integral, then I can just do another substitution. So I'll just let v equals 1 plus 4u. Then dv is equal to, it's equal to 4 du. Then I could just divide the 1 over 4 both sides, so now that'll just be 1 over 8, and then v to the 1/2 dv. Then we can keep going, so that means I have 1 over 8, then plus 3 over 2, and then divide that, so it's times 2 over 3, and then this is, what is it, v 2 or 3 over 2, but you just replace this with, let's see, so this will just be 1 over 12. Replace v with our 1 plus 4u, but then we put back the u for ln of x, so this will just be 1 over 12 and then times 1 plus 4 ln of x, and then 3 over 2. And then plus c, since they're all indefinite integrals. So we combine everything together, we get that the final answer I is just equal to -1 1/2 ln of x, and then plus or minus 1 over 12 multiplied with 1 plus 4 ln of x to the 3 over 2 power plus c, like so. And there we have it. We have a we have evaluated this indefinite integral of a continued function, like so. All right then. So yeah, that's pretty cool if you ask me.